My name is Alex Dufetel, and I'm the product lead for Firebase Backend Services. Today, we want to talk to you about building planetary scale apps using Firebase. Specifically, we want to talk to you about Cloud Firestore, the new database we launched earlier this month. But before I get started, let's do a quick survey. How many people here have used the real-time database? I'm going to get closer so I can see. Wow, OK, quite a few people. How many people here have used functions? All right, almost as much. And has anyone here already played with Cloud Firestore? Wow, that's probably more than I expected. That's great. So first, we're going to talk about how Cloud Firestore addresses some of the toughest problems of building mobile and web apps. We'll then get hands-on with a demo so we can see the database in action. And after that, we'll have two teams who have been building with Cloud Firestore come on stage and share their experience building with the product. Cloud Firestore was inspired in many ways by our experience building the real-time database and by the feedback that we had on the real-time database over the years. So bear with me as I step back and talk a little bit about the journey that led us to building this product. When Firebase launched in 2012, it introduced a fundamentally new way to build apps. The real-time database solved many of the hard problems of dealing with app data. Specifically, it does three things very well that make our lives much easier as developers. One, it allows us to access our data directly from clients. Two, it allows us to access that data in real time. And three, it makes it very easy to build offline experiences. Cloud Firestore does these three things as well, and we'll dive in why we think these things are so fundamental in a minute. At its heart, the real-time database is designed to do one thing incredibly well: sync app state in real time at low latency. But over the years, as adoption of the database grew, usage patterns shifted. The real-time database is being increasingly used across app data as an all-purpose persistence layer. It is also being used by larger and larger apps. And when you stretch the real-time database outside of its core purpose, you face two types of issues. The first is around data modeling and querying. The real-time database can't query over multiple properties. And so you can go around that, but that involves convoluted data structures, usually duplicating data, or client-side filtering, all of which are kind of messy. The other problem is that the real-time database doesn't scale automatically. Beyond 100,000 users, which usually accounts to tens of millions of daily active users, you have to create additional shards. Now, granted, this is a pretty high limit, but wouldn't it be amazing if you could build an app and grow it to planetary scale without having to change a single line of code? And this is why we built Cloud Firestore. Cloud Firestore is a NoSQL document-based database that we built specifically for mobile and web app development. It builds on what we love most about the real-time database, and it combines it with Google's powerful cloud infrastructure. It's flexible to build all types of apps and scalable to grow with you to any size. And this is something that I'm personally very excited about, because before joining Google, I actually spent 5 years building and growing a company that was powered by Firebase services, the real-time database, including the real-time database. We built a real-time collaboration app, and we started using the real-time database because we needed a tool to power our collaborative whiteboarding. And a few weeks in, playing around with Firebase, we instead decided to build our entire app using a real-time database. And with hindsight, it was one of the best engineering and business decisions that we made as a company. It allowed us to focus on building features that really mattered to our users instead of infrastructure that wasn't core to our business. And that is really, I think, a testament to what Firebase is really about. But we also hit some of the limitations I talked about earlier. So Cloud Firestore was really the database that we dreamed of having when we were building our company. So I couldn't be more excited to see it in beta today, and I can't wait to see what all of you will build with it next. And with that, I'll turn it over to Sarah Allen to tell you more about what makes Cloud Firestore so special.
So Cloud Firestore, it's fully supported by all of the Firebase SDKs, which, as most of you know, means that it works on web, iOS, and Android. And these SDKs let your native mobile app, your web mobile app, talk directly to the server, and you don't have to write a middle tier. And that handles the data validation, access control, all that stuff automatically for you. So you can focus on building your business value rather than writing this boilerplate code. So all this works seamlessly because of Firebase Authentication and security rules. So you have some declarative rules that let you say what data you want to be accessible from your client app and what can be readable and what can be writable. The other thing that's really new here is that you can extend it on the server side with Cloud Functions. So as many of you know, server-side code can be really helpful. It's code that's run in a trusted environment, so you can make fair decisions on behalf of your users. You also sometimes have some secret sauce algorithms that you want to have only run in a trusted environment. Of course, we can also coordinate multi-party communication, which is what real-time is normally famous for, including things that run when people aren't always there, that make your app feel more alive, like autonomous agents and bots. So when we talk about serverless, we don't mean there's no servers, of course. We're leveraging the server to do all sorts of things. But it means that you don't have to manage the servers. So you can focus on building your app. The capacity planning, upgrades, maintenance, all of that is taken care of by the system without any scheduled downtime. Also, it's replicated in different regions so that if there's, we hope not, but if there were to be a natural disaster in one region, your data has been replicated and would just be there for you. This globally distributed database scales automatically with usage. So we're building different type of apps today. For a long time, it's become completely expected that every app we build works on mobile and desktop web, of course. So the people who use those apps are starting to expect that they can have multiple devices and it'll all just work. And sometimes it does, but you all know that sometimes it doesn't actually. So we've built that stuff into the Firestore SDK to make it so that you can just build your app normally, and then these experiences can transition seamlessly between people with multiple devices, and then, of course, that extends to multi-party communication as well. So this same syncing, which the SDKs really make easy for you by doing data binding between client and server changes, that same paradigm really allows for a completely different purpose, which is getting stuff on the screen faster. So when you use data binding, you can make it so that the UI elements on your client app are attached to the parts of the server stuff that they're supposed to show. And then you just show your screen as soon as the minimum amount of data is there. And then as the data arrives on the client, it just pops in. And this can make your app feel dramatically faster And that model of programming is just becoming more popular in general. And leveraging the SDKs, it means that that pattern can serve you in these different environments. So offline, you wouldn't believe how normal it has become for people to look at their apps when there is absolutely no chance of connectivity. And so that many of you have probably built these types of apps where you cache stuff locally and then you have to sync up when you're back online, and it can get a little tricky. So we've taken that common problem and put it into the Firestore SDKs so that they sync up with a server so that your app can run offline, and then when you connect, it syncs back up again. And we'll show you that later. It's available on all the platforms, including web. So this is really made possible by a new data model in Firestore. So you structure your data with documents and collections. We based this model based on what we've been watching for years in terms of real-time database developers and how they wanted to model their app and what they were doing naturally that we wanted to enable as their apps were growing and having more and more customers. So we've taken some common patterns and we've built that into the data model. And what we've seen so far is that new developers who are coming new to Firestore are finding it more intuitive to just get started, and it's accelerating the learning curve, which is great. But the really exciting thing is that this data model actually is what allows this scalability. So the key thing is that your client-side query performance is based on the size of the result set, not the overall size of the data that you're querying over. So you build some app, and it's just you and your buddies, other engineers in the office, and you're testing it out, and it works really fast. And what normally happens is then you get millions of records, and it starts to slow down because you have to optimize all your stuff. Well, we developed patterns that means that what works with a small data set will work with a large data set. And it's all about how much data you need to pull down for the client. And we'll dive into that next. So this is the new Firestore UI, which is kind of a data console in the back end of your app. The first column shows the collections. So in this case, we have a single collection called items. In the second column, you can see all our documents. Each document has a unique ID, and this particular app has millions of documents, and you can scroll through them, and it keeps auto-scrolling the way you'd expect. And our app could grow to have tens of millions or billions of documents, and the client-side queries would have the same performance characteristics. In the third column, you can see one of our documents. The documents are structured data. You kind of think of them like JSON. So this is a specific app that we worked on for this conference, and I'd like to invite Jonny Dimond out here with me to tell you more about this app.
Thanks, Sarah. Hi, I'm Jonny, and I'm an engineer on Cloud Firestore. Today, Sarah and I will show you Firestore in action. We'll be showing some of the core functionality and features that make Firestore special. For this, we built an offline-capable progressive web app. The app allows users to submit stories and the community to vote on the best stories and comment on them, similar to Hacker News. The app is built using HTML and CSS and vanilla JavaScript. All of the static content is hosted on Firebase hosting. However, the data is backed by Firestore. And when you load up the web app, it will use the Firestore SDK to load the data directly from Firestore without any additional backends. We store all of the submitted news stories in a single collection called items. Every story is its own document in Firestore and has a unique ID attached. And we save a bunch of metadata about each story. For example, who submitted the story, when was it submitted, and what's its score. When we built the web app, we spent a bunch of time dealing with CSS and making sure the app looks great. However, the integration with Firestore was easy. It was so easy that we could fit the code that powers the front page onto a single slide. I'll walk you through the code line by line. The first thing we want to do is get an instance to Firestore. We do this by calling Firebase.Firestore. This is a pattern you might be familiar with from using other Firebase products on the web. And the Firestore instance will be configured with your default app configuration. Next, we have to tell Firestore which collection we want to query. In this case, we're querying the collection of items. For the front page, we don't want to display any kind of news story. We want to display the top news story. So we have a special property in the documents that tells us the order of the news stories on the front page. So we order by this property. And next, we don't want to display all news stories. We want to limit it to the top 30. So we add a limit. Now we've formulated the query. The next thing we want to do is actually run the query. For this, we call onSnapshot. What happens next is the Firestore SDK will go ahead and establish a connection to the backend if it hasn't yet. It will then issue the query to the backend. The backend will go ahead, fetch the results, and send them back to the client. We then will get a callback with the data, and we can use that to render the page. One of the core features of Firestore is real-time. As the data changes, you want to update UI with these changes. And there's no additional code we need for that. As things change, the backend will make sure to notify the clients, and the SDK will call onSnapshot again. So let's switch to the demo and see this in real life. Here we have a browser that has the app loaded up, and it's showing the top voted stories over the last couple of days. So let's assume that someone submits a story, and it rises to the top really, really quickly. Really, really quickly. So, wow. What are the odds that this story shows up just in this instance? What the SDK does for us is it notifies us, and we can just re-render the UI very easily. There's no additional code required. At the core of Firestore are scalable queries. So let's go ahead and click on the submitter of the top story. This now shows a different page. It shows a page of all the stories submitted by Sarah. However, it's backed by the same data. It's using the same collection. It's just using a different query and filtering out all documents or all news stories that were submitted by Sarah. So let's go back to the slides and look at the code for that. What we can do is we can add filters to our collection. In this instance, we're filtering by who submitted the story. But more, we can start chaining filters. For example, we can say we want to look at documents that were submitted by Sarah Allen, but we want to limit it to documents that have been submitted in the last year. As Sarah mentioned earlier, Firestore is built around scalable queries. This means the performance is based on the size of your result set, not the size of the collection. And this is done by you making heavy use of indexes. By default, Firestore has a bunch of built-in indexes that make the most common kind of queries that you issue just work out of the box. There's no extra configuration required. As your app adds more advanced queries and more complex queries, it might require an index, but we make that really easy too. Let's assume you're developing the app and you issue a query that requires a different kind of index. That query will fail. However, the SDK will notify you about this and will give you a link. If you follow that link, it will bring you to the Firebase console, and it will show you a pop-up dialog to create that index on the fly with a single click. One thing to note is, as you use scalable queries, you might have to put some thought up front on how to structure your data. We have great documentation online on how to structure your data and what kind of queries are supported by Firestore. Firestore also comes with offline support for Android and web, Android and iOS, but we also added support for offline on the web. So let's switch to the demo. We can click on the comments link for the top story. And this page loaded just fine. And I hope you're not surprised, because we're still online. So let's change that and disable the Wi-Fi on the computer. Let's go ahead and refresh the page. And again, the page loaded just fine. We use service workers for the static content, for example, the HTML and CSS. However, the data is backed by Firestore. And Firestore makes sure that even if your device is offline, the data is still provided in your query results. But it gets better. Let's try and add a comment while we're offline. So we added the comment, and it shows up immediately. And even if we refresh the page, the comment is still there. Firestore makes sure that any changes you make while you're offline are persisted and show up in the results when you run the query offline. That is useful, but it would be even better if the query or if the changes are synced back to the backend and to other clients. So let's open up the page in a different browser. So this is simulating a different client on a different device. And not surprising, the comment doesn't show up. We're still offline. We didn't have a chance to actually sync back the data. So let's change that. Sarah, why don't you re-enable the Wi-Fi? So we'll re-enable the Wi-Fi, and a couple of things happen now. One, the computer has to reestablish the connection. Two, the Firestore SDK will detect that the client is back online and reestablish the connection. And once it does that, it will check for any changes that may have happened while the device was offline. When it does that, it sends the changes to the back end, and it will be synced out to all other devices. Sarah, why don't you post the same comment into Slack?
Let's go here, and I've got a team Slack.
Wow. Is that the same comment you just posted right now?
It is.
Let's try that again.
All right, I'll post another comment.
So the comment was posted, and it showed up in Slack. So Sarah, why don't you explain how you use Cloud Functions to build this?
All right. So this is one of my, it's hard to even pick, favorite Firebase features. So let's go back to the slides, and I'll show you how this is done. With just a little bit of code, we push it up to the server side, and we can not only add functionality to our app, but these days, our people are using lots of different apps, and so this allows us to integrate with other apps. So this is all the code for the Cloud function that is triggered when Firestore writes. So I'll just walk it through with you. So the first line is just like Jonny showed you before. He was showing you the client-side SDK code. This is the admin SDK, which looks very similar. So you get an instance of Firestore. You specify the path that you care about, and whenever a document is written in that path, in this case, when it's created, we're registering for an event that will trigger this function on the server side. I'm getting the data out of the event, and then in this case, our team is saying, oh, we want to know about all stories, all comments that mention Firebase. And so in that case, I'll call a regular JavaScript function to post to Slack or otherwise ignore it. So, and then just for completion, this is the JavaScript function that posts to Slack. Slack has a web integration. We can just specify a webhook. So that webhook actually is a simple URL that I'm making a post to which has my credentials in it, and I don't want to put that in my code, so I can put that in my in a functions config. So that's like an environment variable that stores that information. So you can use Cloud Function triggers to connect to all sorts of different server-side APIs across Firebase and Cloud. And so this means you can start to develop your app, and you can do the complete experience using client-side only code, and then add in different functionality, even after your app's already distributed on the Play Store or the iOS Store. So I'm really excited to see, this is just a little peek into what you can do with Cloud Functions. And today, as Alec mentioned, we have a couple of partners who have been out in the wild building stuff with our products. And so I want to invite Clark from Whipper and his team out to tell you about what they've built with Cloud Firestore and Cloud Functions.
Thank you, Sarah. We're really, really happy to be here today. I want to start off by talking about our vision for why we actually created Whipper and the underpinnings for Firebase. So we are at a place right now where Whipper is my lifelong passion for content, and my work-life experiences have been in technology, feature film, comic book publishing, and global video games, including publishers and developers such as NCSoft, Pandemic BioWare, and Riot Games. All roads led here to Whipper. Whipper's co-founders, advisors, and investors hail from a wide range of name brand global companies such as Viber Rakuten, Riot Tencent, Netflix, and Expedia. We are really at a place right now where the content that we're developing is pretty exciting. This is something that where we are is, I'm gonna hand over in terms of content right now because we're running short on time. Dave's gonna introduce both the demo and where we are to date.
Thanks, Clark. Hi, folks. We're going to cut to a quick demo of our product, and then I'll talk about how we got there in terms of Firebase and Firestore. So we can cut to the demo now, guys. Hey, Clark. Will I see you down at the pub?
Hey, Clark. Will I see you down at the pub?
Of course, I wouldn't miss it. Tell Romans he's losing at bar trivia tonight.
So that's Whipper. So I'm Dave, and I'm Whipper's Chief Product Officer. I'm here to talk about our execution strategy and how we found Firebase and then Cloud Firestore. Building a tech company from the ground up is always a daunting task. You need a vision, a team, and the right tools. Clark provided the vision. We started the team together, and now we found the right tools, which is Cloud Firestore from Firebase. How we got there was when Romans, our CTO, arrived at Whipper, he immediately started talking to me about Firebase. He had worked with Firebase at a previous company and had had a fantastic experience with it. So to that end, he started evangelizing, and because I've been in tech for a while, we talked it over, we talked pluses and minuses, and I jumped right in. So we went with Firebase, and here's the thing. We loved Firebase at that point. We totally loved Firebase, but the big challenge that we had were there were a couple of features that we wanted to request in terms of enhancements. So we went back back and forth, and we put together our enhancement requests, and then we were ready to send them over and just see if our friends at Google could help us out with these at all. And then, lo and behold, here comes Cloud Firestore. We were invited to the alpha of Cloud Firestore, and it solved all of our problems, and we were totally thrilled about that. So to tell you a little bit more about the implementation, Romans will go through that for us, and I'll introduce Roman Spermans, our Chief Technology Officer.
Thanks, Dave. Hi, guys. So stories, I'm going to be very quick because we're running out of time. So when I first came to Whipper, Dave just laid out for me the challenge and asked me to kind of help him solve it. And I just was at the gig where with 4 engineers, we moved the platform written in Java. Well, actually, it was a pretty massive prescription management platform written in Java and MySQL using Spring and Hibernate. We just went to Firebase, and it was an amazing journey. At that time, Cloud Functions didn't exist, so we needed a bit of Node.js and GCP to make a few things happen. But then when Firestore was released, and that was this time when I was at Whipper, straight away it solved all our problems that we had with the real-time database, basically mostly around data structuring and querying. And with addition of Cloud Functions, we could totally go serverless, and that whole journey was amazing. So thanks Firebase, thanks for all the great tools. Thank you, guys.
Thanks so much for sharing that story with us. It's so inspiring after working so long on a product to hear stories from the field. And next, for a very different type of app, I want to invite Emery on the stage from HomeAway to talk about how they increased user engagement with this new technology.
Alrighty, thanks. Let's go. All right, hi everyone. My name is Emery Cox, and I'm an Android lead at HomeAway, an Expedia brand company. And today I want to talk about Local, an experiment we built using Cloud Firestore and Firebase. HomeAway is a vacation rental marketplace, and as you might imagine, some of the challenges we face are unique to the travel industry. But we also face the same problem as businesses everywhere. How do we increase user engagement? Thankfully, on this point, our users were kind enough to give us some direction. Travelers want local know-how wherever they go. One thing I love about the vacation rental industry is the community. It's a really warm group of people, and they happen to have exactly what our travelers want: local expertise. So we set out to create an experience bringing travelers and the community together to share local insights. From the outset, we faced the same problems plaguing any new product. How does it work? How do we build it? What tools will we use? In fact, for this project, a primary challenge was simply resourcing, with effectively one person working on the project at any given point in time. Fortunately for us, even at a big company, sometimes the most important thing is just getting a small team together and letting them run. So, with limited resources, we faced a technology choice. Do we use the standard HomeAway tooling, or do we try something different? With the standard tooling, we'd probably end up with an architecture that looks something like a client app serving 2 user experiences with 1 server, 1 database, and a handful of integrations. This architecture is manageable in theory for a team of 1, but we wondered if there might be an accelerator we could leverage. Enter Cloud Firestore. Cloud Firestore bills itself as a real-time database for mobile development. We didn't have first-hand experience with serverless architectures at the time, but we were enticed to test it out based on the promises the product offered. Immediately, Firestore replaced our traditional server database architecture with an SDK, allowing us to focus singularly on the client. As a NoSQL database, it offered a flexible solution for the data requirements of our app and was optimized for our preferred access patterns, providing real-time and offline behaviors for free. While this sufficed for our CRUD operations, like many apps, we also needed some asynchronous behaviors. Here again, Firestore offers a solution out of the box, rounding out the missing pieces of our behavior with first-class eventing support in-app and simple integration with Cloud Functions for ad hoc service actions. We then used the remaining Firebase tools to flesh out the backbone of our application, allowing us to isolate Local from the larger HomeAway platform while at the same time enabling key integrations for an on-platform experience. So putting it all together, we ended up with an Android application where, if my demo runs, oops. All right, putting it all together, we ended up with an Android application where travelers ask for recommendations, travelers explore, and locals will recommend. All right, everyone. So summing it all up, for HomeAway, Cloud Firestore and Firebase really proved an accelerator for our experimental mobile development, driving local from idea to reality and empowering our small team's success. Thanks for the time.
Thank you, Emery. Thank you, Emery. Sorry about the glitch with the demo. A big thank you to the Whipper and HomeAway teams for coming here today and sharing their experience. That was really great. Thank you all for coming. I hope you enjoyed this talk, and I hope we got you as excited about Cloud Firestore as we are. Thank you.